Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. A comparative bar chart is where you have two bars next to each other meaning different things. So it's probably easier just to start drawing it and then we can talk about it as we go along. So we've got males here at 12. And so what we want to do is a bar that is 12 high. And these are going up in twos. So it will be up here. There we go. And then right next to it, we're going to do females, which is 14. And so what we're going to do is we're going to make this go up to 14. And there we go. Now, we need to be able to tell these apart. So what I'm going to do is just shade in the females. And we should do a little key. And we say that if they're not shaded, it's males. And if they're shaded, that is females. Okay, let's carry on with the bar chart. So it's 14 and 6. So notice I've got gaps between the pairs. So we've got 14 and 6, which will be down here. And again, we're just going to shade in the females. And then finally, we've got 8 and 16. So 8 would be here, and 16 would be up here. And finally, obviously, we're going to shade in the females. So we're going to start off by working out what 100% of 120 is. Well, that's obviously just going to be 120. And we're trying to get to 6%. So we always start off by working out 10%. It's always normally useful. And we just divide that 120 by 10. So we get 12. And we try to get 6%. So it'd be nice if I knew 5%. And 5% is nice and easy because we just halve that 10%. So that'd be 6. And if we got the 1% as well, we can get to the 6%. So to find out what 1% is, we just divide the 10% by 10 and get 1.2. So to get the 6%, we're going to add the 5% and the 1%. So we're going to add the 6 and the 1.2. And so we just do 6 plus 1.2, which is just going to be 7.2. And that's our answer. To answer this question, we're going to find the answers to the numerator and denominator, then we're going to divide the two. So 3 plus 42 is 45. 5 times 3 is 15. And what this line means in the fraction, it means divide. So we're going to do 45 divided by 15. So I'm just going to go through the 15 times table and just work out that's 1 times 15, 2 times 15, 3 times 15. So 3 15s in 45. The first thing we need to work out is the fraction that Sarah will receive. Well, if Jane receives 9 over 10, then that just leaves how much of the numerator to match the denominator. So 9 plus 1 is 10, so it leaves 1/10 left for Sarah to have. And the reason that works is that the total amount needs to add up to 1, and 9 over 10 plus 1 over 10 is 10 over 10, which is just 1. So next we need to find out what 1/10 of 60 is. So we know that we divide by the bottom and times by the top. So 60 divided by 10 is 6, and then 6 times 1 is just still 6. So our answer will be £6. So a composite bar chart is where you'll stack the bar charts on top of each other. So we're going to start with this 12 here. And so I'm just going to do a bar up to 12. And these lines go up in twos, so it would be there. And then we're going to do this females. So we've done the males, we're going to do the females. And the females is only going to be 1 high because they're going up in twos. And we need a way of showing male or female, so what I'm going to do is just shade the female there, and I'm going to just draw a key. I'm going to say if it's not shaded, it's males, and if it is shaded, it's females. Okay, next we're going to do the 8 and the 4. So what you can do is just do the whole thing, then split it afterwards. So it would be like that. Shade in the females. And then finally we've got a 4 and a 12. And let's shade in the females there. Now don't spend forever on your shading, as long as it's clear which one's male and which one's female. So to simplify 10 to 22 to 26, I'm going to have to find something that I can divide the 10, the 22 and the 26 by. The biggest number I can do that for is 2. So if you look, 10 can be divided by 5 but nothing else can, 22 can be divided by 11 but nothing else can, and 26 by 13 but nothing else can. The only thing we can divide all of them by is 2. So that will be 5 to 11 to 13. So the answer is 5 to 11 to 13. Percent means per 100. So 8% is the same as 8 over 100. Now we can cancel this down because it wants it in simplest form, so we can halve top and bottom. So it becomes 4 over 50. We can actually halve it again, so it becomes 2 over 25. So the answer is 2 over 25. So football is represented as a quarter of this pie chart. And so if there are 60 students altogether, we just do 60 divided by 4 to find a quarter of it, and that's 15. So there are 15 people who picked football. So we've got to first of all make these both the same units, because at the moment they are different units, and when we have ratios we always want to make sure that they have the same units, and then we can get rid of the units. So I'm just going to make them both into grams. I'm going to do that by timesing the right by 1,000. And the reason I've chosen grams rather than kilograms is you want to always pick the smaller unit. Otherwise you'd be left with a decimal on the left hand side, you'd be 0.2, and that can be a bit more complicated. Okay, so I'm going to remove the units now, and we're just going to focus on the numbers. So we can divide both sides by 100. Straight off the bat, so we've got 2 to 40. We can see we can divide them both by 2. And so we've got 1 to 20. And so it's 1 gram to 20 grams, or just 1 to 20. The easiest way to compare fractions, decimals and percentages is to convert them all into decimals. So I'm just going to convert this percentage to a decimal, and to do that you just divide by 100. And I can convert this fraction by timesing top and bottom by 10, and we know that 4/10 is 0.4. Then I'm just going to put all of these numbers in a place value grid, place value table, and we've got units, we've got tenths, we've got hundredths. Shouldn't need any more than that. So we've got 0.4, 0.43 and 0.27. Now what we do is we start on the left hand side and we find the smallest, because we're looking for it in ascending order, and the smallest tenth is the 2 there, so it's 0.27. So this is our smallest number, 0.27. Now the next two are equal, so we look at the hundredths, and this technically has a 0 there, so 0 is the next smallest. Now 0.40 was 2/5, so make sure you have the original fraction in and not 0.4. And then the largest one is the 0.43, which was 43%. So we're going to start off by filling out this table. So 0 times 1, 0 times 2, 0 times 3, 1 times those, 2 times those, and 3 times those. And we're looking for the probability that the product, which just means that when we times them together, will be more than 2. So which of these are more than 2? Let's circle all the ones that are more than 2. And to work out a probability, it's always the successful outcomes over the total amount. So the successful ones are the ones I've circled, so 1, 2, 3, 4, 5, 6, 7, 8, 9. The total are all of them together, where it's a 4x4 grid, so it would be 16 in total. And so the probability that the product will be more than 2 will be 9 over 16. Just like when you're simplifying fractions, you can't have decimals at the top and bottom. You can't have decimals at the top, at the left and right of a ratio. So we're going to have to get rid of this decimal. And the way we're going to do that is just simply times each side by 10. And that will leave 4, and that will be 60. Now we can simplify this further, because I can divide left and right by 2. So that would be 2 to 30. And I can actually do the same again. I can divide them by 2 again. And that would be 1 to 15. Now you might have just divided by 4, and that would also give you the right answer. In fact, there's a couple of different methods that you can get the same answer with. These fractions have different denominators, so we need to make sure they're the same before we can add these fractions. So we've got 15 and we've got 10. So what we can do is just quickly write out the 15 and the 10 times table. And we don't have to go very far before we realise that 30 is in both of them. So we need to get the bottoms of these fractions to 30. So for 2 over 15, all we do is we times top and bottom by 2 to get to 30. So it becomes 4 over 30. And for 3 over 10, we just times top and bottom by 3, which would make 9 over 30. So we can rewrite this question as 4 over 30 plus 9 over 30. When the bottoms of the fractions, the denominators are the same, we just add the tops, we add the numerators. So that would be 13 over 30. Can we simplify it? Well, 13 is a prime number and 13 doesn't go into 30. So our answer is 13 over 30. Instead of doing 0.43 times 16, what I'm going to do is I'm going to do 43 times 16. So I'm just going to get rid of the decimal and just change it to 43. But I've got to remember what I've done. So how have I managed to do that? Well, I've times it by 100, and that will be important at the end. And to do 43 times 16, there are loads and loads of different methods. Just pick whichever method you enjoy doing or that you find easiest. I'm going to do the grid method, but it by no means is the best method. It's just the one I'm choosing to do. So 43 is 43, and 16 is 10 and 6. So 40 times 10 is 400, 40 times 6 is 240, 10 times 3 is 30, and 3 times 6 is 18. Then I'm just going to add them all together. So 400 plus 240 plus 30 plus 18. And when you add those all together, you get 688. Okay. Now, the problem is that obviously this is not going to equal 688. What we've done though is we've times it by 100. So to find the answer, all we need to do is divide this, undo that times by 100, so divide it by 100. When we divide that by 100, we get 6.88. The experimental probability is the successful outcomes divided by the total number of outcomes. So we're looking for the probability that it's white, so it's going to be 25 over, and we're just going to do 35 plus 25 plus 31, which is 91, and that's our probability, 25 over 91. Be careful when it say total, you must include all of the outcomes, so red, white, and other. So when simplifying ratio, it's very similar to simplifying fractions, but instead of the same thing having to do the same thing to the top and bottom, you have to do the same thing to the left and right. So I'm going to start here by dividing both sides by 100, because I noticed they both have 2 zeros at the end. So that'll give me 10 here and 34 here. Now these are both even numbers, so a nice easy next one to do is dividing by 2. And we get, was it 17? And 5 and 17, well, they're both prime numbers, and so there's nothing we can cancel them by, so it's going to be our answer, 5 to 17. The formula for the area of a triangle is half times the base times the height. Now the base is normally the length on the bottom, but that's not always the case. The important bit though is that the base and the height hit each other at 90 degrees. So this length here is not going to be the height because it hits the base at an acute angle. If we look, it's here. Same with the one on the left. The height is obviously going to be this length here in the middle. So let's put that into our formula. Half times the base, which is 5, times the height, which is 3. So it's going to be half times 15, and that will equal 7.5. Both the length in the diagram are centimetres, therefore the area will be centimetres squared. So we're asked to reflect this shape along the line y equals x, and y equals x is a diagonal line where all the x values are equal to the y values. So at the bottom here we've got x is 10 and y is 10, so that coordinate would be 10, 10. And then obviously this coordinate 4, 4, etc. So we need to reflect it across this line. And so if I pick a point, I'm going to pick the top one. We can see it goes 4 diagonals to hit that line. So 1, 2, 3, 4, so it will go another 4 diagonals. So that will be one of the coordinates there. And I'm going to do the same with the bottom one. So 1, 2, 3, 4, 5, 6 diagonals. 1, 2, 3, 4, 5, 6 diagonals. So it will be there. And then finally, I'm going to do this slightly harder one. So we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Kind of goes over the other one, ends up here. So if we join these up, and we need to label it B. So 3 as a percentage of 10, the first thing we can do is write that as a fraction, so 3 over 10. And then I can get the bottom to be 100 and the top will become the percentage. So I can times top one here by 10, so that becomes 30 over 100. And percent means per 100. Here we've got 30 per 100 or 30%. So the answer is 30%. So the first thing we're going to do is write this as a ratio between the fractions. So we're going to have green to black. Now it says that a quarter of the counters are black, and therefore the remaining counters will be green. So if a quarter are black, that leaves 3/4 to be green. And what we can do here is on both sides of the ratio, what I'm going to do is just times it by 4. So I'm just going to times 4 both sides. So 3 divided by 4 times 4, because over 4 just means divided by 4. So 3 divided by 4 times by 4 just gets rid of the fraction. And 1 divided by 4 times 4 is just going to be 1. Now, this might surprise some people because they will probably think it's a ratio of 4 to 1, but we can show here that it's a ratio of 3 to 1. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call x, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got we have a set of parallel lines here, and we have a set of z angles, which we know is alternate angles. So the reason for that is it's alternate angles. And always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B, it's just going to be 360 take away 135, and the reason for that is angles on a point. We've run out of space. Okay, so we're going to do 360 take away 135, which is 225, and so our answer is 225. To answer this question, we need to know what an equation, expression, formula, and identity is. So the formula is basically an equation, but for real-world things. So area equals pi r squared. It's where the letters actually mean something. Expression is just algebra without the equal sign. So 5x plus 3 would be an expression. An equation has an equals, and it can be solved. So you can find out what x is or find out what a is. And an identity is true for all values of that letter. So an example would be x times x equals x squared. That's an identity because that's true for all values of x. So looking here on the right hand side, we've got 3x plus 2x. But if we imagine x is 10, so 3x would be 30 plus 2x would be 20, 30 plus 20, well that will equal 5x, 5 times 10. And actually this is true for all values of x. And the reason it's true for all values of x is we know that 3x plus 2x, this right hand side here, equals 5x. They're the same thing. Now normally with an identity, it's shown with 3 lines. Now in the exam, this type of question, it won't be shown with 3 lines because that kind of gives it away that it's an identity. But this question is definitely an identity. And you can't solve it because it's true for all values of x. So yes, x could be 10, x could be a million, x could be a third, x could be anything. So we know that 171 is 3 times 3 times 19. And what we do is we just compare 171 with 342. And we know that 171 times 2 is 342. So therefore 342 will have the same prime factors as 171, which is 3 times 3 times 19, but it will also have a times 2 in there. So the answer will be 2 times 3 times 3 times 19. Whenever we solve, we've got to get rid of any fractions or brackets first. Now looking at this, there's no fractions, but there are 2 sets of brackets. We've got the set of brackets here, and we've got the set of brackets here. So we're going to expand them to get rid of them. And you can use any method you want. I'm just going to use this kind of grid method. So we're doing 4 times, and inside the brackets we've got 3x plus 5. So I'm going to times those out. 4 times 3 is 12, so that'll be 12x. 4 times 5 is 20, so that's going to be positive 20. And I'm going to do the same for the other set of brackets. Now on the outside of the brackets we've got to be careful here. It's not a 5, it's a minus 5. And inside the brackets is an x and a 2. So minus 5 times x is minus 5x. Minus 5 times 2 is minus 10. So when we put it all together, we get 12x plus 20 minus 5x minus 10. And then the rest of it is just equals 52. So I'm going to start by putting my lines in because we're solving. And I'm actually just going to start by collecting the like terms on the left hand side. So 12x take away 5x is going to be 7x. And 20 take away 10 is going to be 10. Okay, now we need to get rid of the plus 10. So we're going to take away 10 both sides. So we've got 7x equals 42. And then we need to get rid of the times 7. So we're going to divide 7 both sides. So x equals 6. We can write the equations of all linear graphs as y equals mx plus c, with m being the gradient and c being the y-intercept. The easiest thing to find is the y-intercept because it's just where the line crosses the y-axis, so that's going to be minus 2. We're going to use that point, so the point we've just drawn on, and we're going to have to find another point to find the gradient. Now, I don't really like this point because I don't really know where that is, and we've got to find a coordinate we know the coordinates for. So looking at this, this is a nice coordinate here. And what I'm going to do is just draw a right angle triangle between the 2 points. Try and get it as nice as I can. And we're going to work out how far up and how far right we went. Well, we went 3 right and 4 up. Now, to find the gradient, what we want to do is we find out how much y has changed, so change in y, so that's how far up it's gone, which is 4, and put that over how far right it's gone, so the change in x, which is going to be 3. So our equation is going to be y equals 4 over 3 x minus 2. So I'm going to start just by writing out the equation. And I can put my lines in. Okay, we're asked to make x the subject, so we're going to first of all add 10 to both sides. In fact, I'm just going to move all this over a little bit so I've got a bit more space. Okay, so we're left with m plus 10 on the left hand side, and we've got 1/7 x on the right hand side. Now to get rid of the 1/7, what I can do is just times both sides by 7. So 7 brackets m plus 10 equals x. So x therefore would equal 7 brackets m plus 10, but it says expand your answer fully. So we're just going to expand the brackets, 7m plus 70. There's a few different methods to find product of prime factors, but I prefer using the bubble method. So we put a circle around 75 and we want to split it up into 2 numbers, so 2 numbers that multiply together to make it. I always pick the smallest that I can think of, which is normally 2, but in this occasion the easiest one for me would be 5. I think also 3 goes into it, but 5 to me seems nice and easy. It doesn't always have to be the smallest that I pick. So 5 times what is 75? Well, 5 times 15 is 75. And then to make 15, we're going to do 3 times 5. And the reason why I've done some of these bubbles in red is that those are the prime factors, which means they can go to 1 and 5. But if you do 1 and 5, you'll be there all day. So we always stop when we do the prime numbers. And so we're going to write these in a list. So 3, 5, and 5. The product means that we put a times sign between them. But if you notice here, we've got 5 times 5. So a different way of writing that in index form is 5 squared. So our answer will be 3 times 5 squared. So here we're asked to find how many bread rolls we can make. We've got 89 kilograms and it takes 0.08 kilograms to make a bread roll. Something we can do is convert these into grams, or we can just keep it at kilograms, but I've got a neat little trick. And the trick is, if you've got a decimal when you're dividing, as long as you do the same thing left and right, you can multiply them by 10 or 100. In this case, we're going to multiply both by 100, because it will make the division a lot easier, because it will make this right hand side, instead of 0.08, it will just make it 8. The reason we can do that is 89 divided by is the same as 89 over 0.08, and as a fraction we can just times top and bottom by 100, so it would be this over 8. So now we can do the bus stop method. So 8 on the outside, and in fact I might use a straighter line here. There we are. And we've got 8,900 on the inside. So 8 into 8 go 1, 8 into 9 go 1, remainder 1, 8 into 10 go 2, remainder 2, and 8 into 20 go 2, remainder 4, and 8 into 40 go 5. Now it says how many bread rolls can we make. Now we can make 1,122 and a half. Well, half doesn't really count, so we're just going to say 1,122 whole bread rolls. Yes, we've got half a bread roll left over, but we are asked how many whole bread rolls can we make. There's a very specific way to draw an angle bisector, and you start off with a pair of compasses and put the point on B, and then draw an arc from B. And it doesn't matter what the distance is, as long as it's kind of roughly maybe halfway between A and B. It doesn't matter what the distance is. And then at the 2 points, so here and here, that our arc intersects line AB and BC, we're going to draw another arc up here. So I'm just going to show you, because it's normally easier. So an arc over here, and I'm going to do an arc from the other one over here. Then what I'm going to do is I'm going to join where the two lines join with where the two arcs join. And that is how you do an angle bisector. All of the arcs leave on the diagram because they are going to get you the marks. Arcs for marks. To divide mixed numbers, we need to convert them to improper fractions first. And to do that, we just do the big number times by the bottom and add it to the top. So 2 times 5, which is 10, and add it to the top, which will be 13 over 5. And the bottom, the denominator, stays the same. Divided by, and we're going to do 1 times 2, which is 2, add to the top, and we get 3. So it becomes 3 over 2. Then we're going to keep the first fraction, flip the second fraction, and change the sign. So it becomes 13 over 5 times, and then we're going to flip that, so it's going to be 2 over 3, times the tops would be 26, times the bottom, which would be 15. Now 26 over 15, there are 1/15s that go into 26, so that'd be a big 1, and that leaves a remainder of 11, so it'd be 11 over 15. So our answer would be 1 and 11 over 15. So to find the locus of points that are 10 centimeters away from a point, you need to measure 10 centimeters on a pair of compasses, and then you put the point at A and draw them. Now I'm going to try my best to do this. It's probably not going to look perfect, but I'll do my best. And the length here, which is supposed to be, probably isn't exactly, but this part here is going to be 10 centimeters to get the full marks, and obviously you want the circle to be a little bit nicer than the one I've drawn, but try and get it as perfect as you can. And the best way of doing that is just don't push down too much and just move the page around with your compass being stationary. The most important first thing that we do is whenever you square something, you times it by itself. So we're going to rewrite this as x minus 15 times x minus 15. And then the way we approach this is exactly the same as we've done with the other ones. We're going to do a multiplication grid. And we're going to do x minus 15 at the top, x minus 15 at the bottom. Then we're going to do x times x, which is x squared, x times minus 15, which is minus 15x. Same again here. And then we've got a minus times a minus, which is a positive 225. Put all the terms together. Now you can see here that we've got the x terms here that will add together. So that would become minus 30x plus 225, and that's actually our answer. So it's x squared minus 30x plus 225. So angles on a point add up to 360, and we are given the values of the angles, but in terms of r. So we know that r plus 9r plus 20 will equal 360. So we've got an equation here we can solve. So first of all, let's add the r's together. And so that will be 10r plus 20 equals 360. Then we're going to subtract the 20 from both sides. So we have 10r equals 340. And then we're going to divide by 10 both sides. So we have r equals 34. So our answer is 34. There's a very specific way to draw a perpendicular from a line. What you do is you get a pair of compasses and measure roughly 3/4 of the way between A and B, and draw an arc from point A. And we're going to draw an arc from point B. And you can see that the two arcs intersect here and here. So what we're going to do is just draw a straight line that join up where they intersect. Leave your workings out, your arcs, on the page when you do this to make sure you get full marks. So we're going to start just by writing this out. So m equals 7 brackets x minus 10. And we're going to put our solving lines in. I'm going to start by expanding the brackets. And we don't need to. We could divide both sides by 7, but I think this is a bit easier. And we're going to subtract, or we're going to add 70 to both sides. So we're trying to get x as the subject. So we're trying to get x on its own. And we're next going to divide both sides by 7. So we have m plus 70, all of that over 7 equals x. So x equals m plus 70 over 7. I'm just going to write the question out, so we've got a little bit bigger writing to play with here. And it doesn't actually matter which method you expand these brackets with. I'm going to use Smiles and Rainbows. So we multiply the 8 by the 10x, which will make 80x, and multiply the 8 by the 4, which will make 32. Now here we've got a minus 5 on the outside, so we do minus 5 times 8x, which is minus 40x, and minus 5 times minus 4, which is actually plus 20. And a lot of students will write take away 20 there, but that is a minus 5 on the outside of the brackets there. So it's minus 5 times the minus 4 there will give you a plus 20. Then 80x take away 40x, which will give us 40x. And 32 plus 20, which would be 52. So our answer would be 40x plus 52. To work out the area of a rectangle, we just multiply the width and the length. Here they are mixed numbers, so all we do is the width times the length. Now when you multiply with fractions, always make them top heavy first, or improper, and to do that you times the big number by the bottom and add it to the top. So we're going to do 1 times 2 and add it to the top, so 3 over 2. Same with this one, 1 times the 3 at the bottom, added to the top. 1 times 3 is 3, add to the top is 5. Now we've got to get the numerator, we don't need to get the numerator the same, we're multiplying. All we do now, really easily, is just multiply the tops and multiply the bottoms. So we've got to convert 15 over 6 into a mixed number because it asks for a mixed number. So 15, how many 6's go into 15? Well, we're first of all going to have 2 whole ones. And how many left over? There are going to be 3 left over. Now, 3 over 6 is the same as 1/2 because we can divide top and bottom by 3. So our answer is 2.5. So we're looking to write a formula for the cost in pounds of hiring a microwave for X amount of days. So the cost is C, so it's going to be C equals, and it says it's going to be 55 pence a day. Now it wants the answer in pounds, so we need to convert this 55 pence into pounds. So that's going to be 0.55, and it's going to be 0.55 times the amount of days. Well, it says the amount of days is X, so it's going to be 0.55x. Then it says that there's just a one-off cost of £15, so you're going to have to pay £15 regardless. So we're just going to add 15 onto that. So the answer would be C equals 0.55x plus 15. So I'm going to start off just with a quick sketch, and we know that the bearing of B from A is 85 degrees. So we're going to have A here and B here. And let's just draw a line between them. And let's do both our north lines. And so we know that this angle here is 85 because it's the angle on the bearing of B from A, so it's 85 degrees. So now it says work out the bearing of A from B. So the first thing we can do is actually just draw a line going down here, and we know that this angle here will also be 85 degrees because of alternate angles. It's always best to write that down somewhere, so we can just put in brackets here alternate angles, and we know that this angle here is going to be 180 degrees because it's a straight line. And I'm not a fan of doing the reasons on the diagram, so maybe perhaps I should have labelled this an X and this a Y and written X equals 85 and Y equals 180 somewhere else. And so to work out what the bearing is, I just need to do 180 plus 85. So 180 plus 85 is going to be 265 degrees. So we need to first of all work out the amount of machine minutes it takes to make a toy. And what we do is we multiply the amount of machines by the amount of minutes. So 5 times 40, which would be 200. So if we had one machine, it would take 200 minutes to create one toy. Here we asked, well, okay, what if we wanted a toy every 8 minutes? So we get the 200 and we divide it by 8. And when we do that, we get 25. So if we had 25 machines, we would be able to make it every 8 minutes. And the logic here is 5 machines. So this is machines, and this is minutes, is 40. Then 8 minutes, if you think about it, we divide that by 5 to get to 8. And so if we divide the amount of minutes by 5, we actually times the amount of machines required by 5. So this is called an inverse relationship. So if one doubles, the other halves. If one divided by 5, the other will times by 5. So our answer here is 25 machines. So sometimes easier with these questions to multiply both numbers by, say, 10 or 100 or 1,000. So if we look at the 0.06, if we times that by 100, it would make the question a lot easier. But with a division, if you times one of the numbers by 100, you have to times the other one by 100. So we just go times the 30 by 100, and times the 0.06 by 100 to make that 0.6. And this actually is the same calculation as 30 divided by 0.06. The reason being is that you can write that as a fraction. And you know with fractions, you can just times the top by something and times the bottom by something. It doesn't change the fraction at all. It just keeps it exactly the same. So we're going to use the bus stop method to find out what that is. So we're going to divide that out. 6 doesn't go into 3, so carry that. 6 is into 30, go 5, 6 into 0, 6 into 0. So that's going to be 500. When we multiply numbers, it doesn't actually matter which order we multiply them. So we can do 2 times 4 times 10 to the power of 8 times 10 to the power of 9. 2 times 4 is 8. And when we multiply two powers with the same base, we add the powers. That's going to be 10 to the power of 17. So our answer is 8 times 10 to the power of 17. First thing I can do with this question is write it as a fraction, because divide just means over. So we're going to have 42 times 10 to the power of 11 over 7 times 10 to the power of 2. And we can actually split those fractions up. So we've got 42 over 7 times 10 to the power of 11 over 10 to the power of 2. And you can see we're just doing it separately. So 42 divided by 7 is 6 times, and then with dividing, or as a fraction, when we divide powers with the same base, we take away the powers. So 11 take away 2 is going to be 10 to the power of 9. So it's going to be 6 times 10 to the power of 9. When it's said that y is inversely proportional to x, it means that y changes as 1 over x changes. And to write this in an equation, all we do is we just write y equals k over x. Now k is something we need to find. So what we need to do is find out what a value of y and a value of x are somewhere on the graph that would be formed from this, and we've got that in this question. So we know that when y is 7, then x is going to be 7.9. And what I need to do now is just draw my lines down. And what I'm going to do is I'm going to just times both sides by 7.9. And so we have k equals, and it'd be 7 times 7.9, which is 55.3. So we know that k is 55.3. So I'm just going to rewrite this equation here, or this formula here. But instead of k, I know that it's going to be 55.3. So our answer is y equals 55.3 over x. First thing we need to do is expand this quadratic here. So put down two sets of brackets with an x at the start of each of the brackets. And we've got to find two numbers that multiply together to make minus 15 and add together to make that 14. So thinking about it, it's going to be minus 1 and 15. That works for both of them, yep. We get the left-hand bracket equal to 0. And we solve. So we're going to add 1 to both sides to get x on its own. So x equals 1. So that's one of our solutions. We do exactly the same thing to the other bracket. Get it equal to 0. So we're going to solve it. So we're going to subtract 15 from both sides. And we get x equals minus 15. So that's our other solution. When we multiply numbers, it doesn't actually matter which order we multiply them. So I can actually rewrite this as 7 times 9 times 10 to the power of 2 times 10 to the power of 9. 7 times 9 is 63. And 10 to the power of 2 times 10 to the power of 9, we add the powers, so it'd be 10 to the power of 11. Now here we've got a problem. It looks like standard form, but it is not standard form. Because standard form has to be a number between 1 and 10, but not including 10. And here we've got 63. So what I'm going to do is just quickly write out what number this is. So we've got the decimal point here. And you don't need to do this, but I find it a bit easier to show what we're doing. So here we've got 10 to the power of 11. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We fill these all out with zeros, and that's the number we've created here. A lot of zeros. Now, to make it a number between 1 and 10, not including 10, the decimal point, it needs to be here. So we want that to end up with 6.3 times 10 to the power of, well, let's work that out now. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 10 to the power of 12. Now you don't need to do all the working out I've just shown there. You just need to know when you convert that 63 into a 6.3, you need to add 1 to the power. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4, and 11 take away 14 is minus 3. Then I'm going to pick a point on my shape, and the the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a minus 3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. So to answer this question, you need to just know the answer off by heart. There is a diagram that can help us actually get there. And if we just draw a right angle triangle and put the lengths as 1, we've got right angle here, we can use Pythagoras, a squared plus b squared equals c squared, to work out the fact that this is going to be root 2. Because it's an isosceles triangle, this angle here is going to be 45 degrees. And same with the bottom right one, but we're not interested in that. When we label it with our marked angle here, we've got the adjacent is here and the hypotenuse is here. Now we know from trigonometry that cos x equals a over h. The angle is going to be cos 45, and a is going to be 1, and h is going to be root 2. Now, this is a bit of a strange one with 1 over root 2, because we need to actually be able to rationalise the denominator. And basically what that means, if you haven't done surds yet, or you aren't doing surds, is you times top one by root 2. And so we end up with root 2 over 2. So if you ever see 1 over root 2 is absolutely fine as an answer, but if you ever see the answer as root 2 over 2, the two are actually exactly the same. So writing 1 over root 2 is fine, or writing root 2 over 2 is also correct. So we can write this as a fraction, so it would be 2.84 times 10 to the power of 11 over 4 times 10 to the power of minus 2. What we can do is split this up into two fractions, so 2.84 over 4 times 10 to the power 11 over 10 to the power of 2, or minus 2. Okay, so we're going to start by doing 2.84 divided by 4. So we're going to just do the bus stop method, so 4 on the outside, and we've got 2.84 on the inside. 4s into 2 don't go, so carry the 2 across. 4s into 28 go 7, and 4s into 4 go 1. So it's going to be 0.71 times, and then the rules of indices say that if you divide two powers of the same base, they're both 10, then you just take away the power. So it's 11 take away minus 2. Now the two minuses, the two takeaways, actually convert to a plus, so it would be 11 plus 2, which would be 13, so it would be 10 to the power of 13. Now we've got a bit of a problem here, because standard form must have a number between 1 and 10, and not including 10, at this position here, and this is obviously less than 1, so we need to convert this into standard form. So what we can do is just write the number out again. So I'm going to write this as an actual number, so it's 10 to the power of 13, so it would be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Fill in the zeros. So it'd be 7, 1 and all those zeros. And then I'm going to put it back into standard form. Now the decimal point will need to be here to make it 7.1. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 7.1 times 10 to the power of 12. Now, with a bit of practice, you don't need to write out the whole number. You'll be able to just know that if you convert that into 7.1, then you just need to take away 1 from the power. But if you're not sure, and it's not an unreasonable number like 10 to the power of 105, then it's just worth sometimes just writing out the actual number and being 100% sure that you've got it the right way around. So we're going to first of all realise that this is a right angle triangle, and we've got two lengths and an angle involved, therefore it's going to be trigonometry. So we're going to just label the sides first. The one opposite right angle is the hypotenuse, opposite the marked angle is the opposite, and the one between the right angle and the marked angle is the adjacent. Now the adjacent doesn't have a number or a letter next to it, so it's not interesting, so get rid of that. Next we're going to do our trigonometry triangles. And so we've got SO, CA, TOA. And we are just crossed out the adjacent, so we don't need this one and we don't need this one. And we're going to end up with SO, which is short for sine the angle equals opposite over hypotenuse. The angle is marked as x, so sine x equals √3 over 2. You need to know from memory that sine 60 is √3 over 2. And notice here that the x therefore is going to equal 60. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.